Welcome back, Wild Kits. In this video, we'll be going over the key features of a quadratic equation and its accompanying parabola. So we have a list of items from this problem that they want us to identify and point out. And so let's just go ahead and jump right into it. So the first thing that they want us to point out is the vertex. And if we look over at our equation, by the way, this equation matches this graph, and that graph matches that equation. So if we're looking at our equation, we can pick out our vertex directly from there. So our vertex is going to be -1 comma -12. Remember, x plus 1 means we're moving to the left one. Minus 12 means we're going down 12. And if we look on our graph, that matches what's in our equation. So our vertex is -1 comma -12. And I'm just going to put a V for vertex. So here is A. And now we're done with A. The other thing that they want us to point out or identify is the axis of symmetry and the equation for the axis of symmetry. So remember, the axis of symmetry is the vertical line that splits the parabola in half. And so I can go right on my graph and just draw in a dotted line to show where that axis of symmetry is. So here it is. So this is your axis of symmetry. And if you notice, and I'm just going to also highlight it just to make it easier to look at. If you notice, the axis of symmetry has the equation x equals -1, which is the same value as the x coordinate of your vertex. So you kind of get those two pieces of information when you pick out the vertex. You get one, your vertex, and two, the axis of symmetry equation. So the equation, again, is x equals -1. And that takes care of part B. Okay, and then part C is asking us to pick out the vertical stretch or compression. So for that, I'm going to highlight this. So for vertical stretches and compressions, you're going to look at your A value. So if you're taking notes, that's going to be your A value. And that's going to be the number that's right in front of your parentheses. So that's 3. And since 3 is greater than 1, I'm going to have a skinnier parabola, so that's considered a stretch. And since the 3 is positive, that also tells me that my parabola is opening up, which matches my graph yet again. So we've got a vertical stretch of 3, aka the A value equals 3. Okay, and that takes care of part C. Okay, so then part D is also asking us to find the maximum or minimum. Okay, well, since my parabola is opening up, that means I'm going to have a minimum value. And the minimum value is going to be the same point as your vertex. So you've got a minimum point at -1 comma -12, which is the same as your vertex. Okie doke. The next thing we want to take a look at is figuring out our domain and range. Okay, so for your domain, well, domains for all quadratic functions are going to be the same, and those are all real numbers. So there's a couple different ways you can write that. We can say all real numbers by writing all and then this fancy looking R here with like 2 bars here, and that shows that it's all real numbers. We can write it from -infinity to +infinity, and we can also write it in set notation. So we can write it as -infinity is less than x, which is less than +infinity. Okay, cool. Now let's go ahead and take care of our range. So our range is not going to be, whoops, that's not part F. We want to do range. So our range is not going to be all real numbers. For your range, remember, we're looking from the lowest point to the highest point. So our range from low to high vertically. So the lowest point on the graph, lowest point is at the y value of negative 12, and that's part of your vertex, right? And if we look at the top of our graph, these are cut off, so that means that graph is going up forever. So the way that we would write that in interval notation is we would write negative 12 comma to infinity, and we want to bracket at negative 12 because we're including that value in our range, and a parentheses after infinity. If we're writing it in set notation, we can show that as y is going to be greater than or equal to 12. And then you can also write that as negative 12 less than or equal to y, which is less than infinity. Okay. And then for part F, and I'm going to move over here because I'm running out of room here. Part F is asking us to find our y-intercept. So remember, your y-intercept is where your graph crosses the y-axis. So I'm going to look on my graph for that one. So I can see right here, this is the point where my graph crosses the y-axis. And that's at the value 0, comma, negative 9. Okay, so here's a little preview of our next part in quadratic. So just like there's y-intercepts where your graph crosses the y-axis, sometimes parabolas will also have x-intercepts. I say sometimes because not all parabolas have x-intercepts. So x-intercepts, or where the graph crosses the x-axis, can also be seen on the graph. And we can call x-intercepts, we call those roots, and we also call those zeros. Those three names are synonymous, so we'll use those interchangeably. So they mean the same thing, and we can look on our graph for that. So if I'm going to zoom in here, just zoom in really quick. I can see one of my x-intercepts is at this coordinate, which is at 1, comma 0. Here's one x-intercept. And I've got another x-intercept over here, which is at negative 1, 2, 3, negative 3, comma 0. So those are your two x-intercepts. And you want to make sure that you write both of those down, because if you don't, then your answer is incomplete. Okay, thanks for watching. Go ahead and try some of the other problems.